Okay, so welcome to Lightning Talks. This is the last session for the day, I believe, hopefully. But I'm already 2 drinks in. We're just going to kind of run through these. There's 3 presentations. I'm going to go last. And so first, what was your name?
Weihan.
Weihan. All right, go for it.
Good afternoon. I am the co-founder and CTO of AeroFS. So I'd like to talk about how Docker helped AeroFS deliver awesome user experience, or even better user experience, to our customers, and how Docker can do the same, can help you to achieve the same. All right. So AeroFS is a enterprise file collaboration software, and you can think of it as a job box behind corporate firewalls. And privacy-conscious customers use us in critical industries such as national security, healthcare, finance, telecommunication, construction, and so on and so forth. So the way we deploy, So we used to ship the entire software as a virtual machine image. And the IT admins of client companies, they launched this single image in their private infrastructures into an AeroFS private or AeroFS virtual appliance. And there have been 3 problems with our previous approach of delivering such an appliance. The first one is multiple different cloud providers require different virtual machine image formats. And maintaining these different formats, multiple of them, is kind of painful and expensive for us. So we ended up with supporting only a few of them, very few of the cloud providers, such as EC2 and OpenStack. So if, say, a customer happens to run their infrastructures on DigitalOcean, the only thing we could tell them and the only picture we could show them is, sorry, but you don't have many options. Yes, if for those who can appreciate this picture, you must have been watched the Game of Thrones videos, TV shows. So this is the first problem. And the second one is downloading a multi-gigabyte VM image file is rarely a fun experience. The file is too big, and downloading it takes too long, and watching the progress is so boring. And because this download step is the very first impression any user would get whenever they try AeroFS for the first time, and because user experience is such an important matter to us, we care user experience a lot at AeroFS. So we really wanted to reduce frictions during this initial setup and the download size as much as we can. Third, the user experience of upgrading our appliance to a new version is even more painful. Not only does the user have to re-download this gigantic file all over again, they also need to make a backup from the old appliance, destroy it or stop it, find a slot to launch a new VM, restore this backup into this new VM, and finally update their networking settings and DNS servers to make this new VM alive. The entire procedure is so complicated, and it's so easy for humans to make bad mistakes along the way. So upgrading our appliance really takes a leap of faith. And none of our customers really look forward to it. So these are the 3 problems we want to solve. So in the past few months, we architected our entire appliance and converted about 30 services inside the appliance into Docker containers. And as a result, all these 3 problems went away in one go. And that is amazing. So now let's take a look at how the new system works very, very briefly. This picture shows how the bootstrap process of the new Docker-based architecture. Instead of a giant file, the user only needs to download a single 9 kilobyte cloud config file. And with this file, the user then launches a generic Linux-based operating system on the favorite cloud provider of their choice. Any cloud provider would work. And for the time being, the only Linux-based based operating system we support is CoreOS. At boot time, the cloud config instructs the system to download from a Docker registry a special container, what we call the loader. The loader container has two parts. The first is a program called Crane. Crane is a third-party tool to manage multiple containers on the same host. If you have experience with Docker Compose, then you understand what I'm talking about. Crane is very similar to Docker Compose. The second part of the loader is a Crane configuration file. Just like Docker Compose.yaml, it defines all the containers required by an application, and as well as their interdependencies and runtime parameters. Once this loader container is launched by the system, it reads from the file, downloads all these containers from the registry, and launches them at once using the Crane program. And this is the complete bootstrap procedure, which is much better than before because the user no longer need any download of the big files, and also they can observe the nice web UI in this bootstrap process when the loader is downloading the containers. And on top of it, we also developed what we call in-place upgrades of an appliance. Assuming this is the current version of the running system, whenever the user wants to download to upgrade the system to the next version, the only thing they do is to go to the management web console, make a single button click, and the web UI then triggers an API request into this loader container. On receiving the call, the loader downloads a new version of itself from the same registry. The new loader also has a configuration file, which can define a very different set of containers and their topologies than the old loader. When it's launched, it again downloads and launches the new set of containers. After the new system, and the two systems now runs at the same time within the same VM. Once the new system passes sanity checking, the new loader will destroy the old system, which concludes an live upgrade. So with Docker, we delivered better user experience and thus more love to our dear customers. And in return, our customers love us even better, especially the increasing number of users who already know, love, and adopted Docker. It turned out everyone loves Docker, really, especially the IT admins that we are dealing with in those big enterprises. So last but not least, we also want to spread our love even further. So for anyone who ship applications to enterprises, we open sourced our efforts as an open source project called Ship Enterprise at GitHub. It allows any developers to build multi-container virtual machine applications and deliver good user experience to their dear customers. So I encourage you to check it out after the session. My name is Wei Han, and you can find me on Twitter with my full name. Thank you.
Thank you, Wei Han. So we have, we're gonna switch laptops here. Can you take your laptop? We have 2 more 10-minute presentations for these lightning talks. Next, we're gonna listen to Christopher from Joyent.
All right. Hey. All right. Hi. I'm Christopher Harrell from Joyent. I'm in charge of I'm the manager of the solutions engineering team. I was told to put my Twitter handle up there. That's actually my handle for everything. So if you're looking for me on IRC, for better or for worse, that's me. I wanted to talk today about my team's experience maintaining the official Docker node image. Does anyone here actually maintain an official Docker image? What image do you?
Alpine.
Ah, I love
Actually,
Alpine. Yeah, Alpine.
does.
Oh, nice. Okay. So even if you don't, this actually covers a lot of things that have to do with building images anyways that I think should be broadly useful. It's a little bit of a joint. We're the container company, and we've been that way since about 2006. You might know us from the joint public cloud. We have public cloud hosting. We also offer private cloud software. It's called Smart Data Center. The GitHub repo is up there because it's all open source. So if you want to go and try it, you can. And of course, I have to do a shameless plug. One of the things that we have with Smart Data Center that's available in our software in the cloud is something called Triton. So you can spin up Docker images in a data center on bare metal. You'd use the Docker commands just like you would for running from your laptop. It's pretty cool tech. We run Docker images natively in SmartOS zones. Like I said, we turn basically the entire data center into a Docker host. And also, one of the other things we do is we have these things. We do Linux containers, so you can run Linux at bare metal speed. And my team actually is responsible for building those. So solutions engineering, I always feel like I have to explain what that means. So we're basically the image team. Just about every image that is in the joint public cloud that's available to Smart Data Center users or SmartOS users, my team builds them. So SmartOS containers, KVM Linux, so Debian, CentOS, et cetera, FreeBSD, Windows. We don't build the Ubuntu images. That actually is handled by Canonical that I work with them as a partner. And of course, I also mentioned this before, the Linux Triton container images that we build as well. That's actually been really fun. It's very similar to, if anyone here has built like an image from scratch for Docker, it's pretty similar. You're tarring up a root file system and that sort of thing. But what I want to get into is, so we also maintain the official Docker Node.js image. So I'm assuming, probably a lot of people are familiar with the Docker Node.js image. Hands up. Hands up. Okay. Oh, good. So yeah, obviously you've seen it on the registry. There's the GitHub repo. It's kind of popular. So that number you see right there, that's actually wrong. This screen cap was taken like, I think a week ago, and so we're already at something like 1 million downloads. That number turns over pretty quickly every week, actually. Yeah, so it's like, it's popular, but it's like popular, right? It's like popular in quotes, but it's still, it's still up there and for the top images. So the actual Docker Node.js image, we took it over from Docker a few months ago. So that had some really great advantages actually. A lot of stuff was already set up for us. So there's really great scripts for updating the image. Everything was pretty well established. And even beyond that, there's some fantastic resources. So there's a great README on GitHub. All the Docker docs are fantastic. There's a IRC channel that I used when I first took this on that was super helpful. But we also had some prior history to get familiar with. So the base image, we had to realize what was being chosen. So in this case, it's the build pack depths Jesse image. I don't know if anyone's familiar with that, but it's huge. It's a big image. It's basically got everything you could want in it if you want to build something. Super helpful if if you want to compile like any kind of npm module. Chances are it's got what it needs to build it, but it's a big image. So there's sort of this compromise between how useful it is and the image size. I'll touch on that a little bit later. There was also pre-existing tags and variants for the image as well for all the different versions and stuff that are offered, and I'll get into that. The other thing we had to sort of get familiar with was the image workflow. So there wasn't that many people here, obviously, who update the official images, but there's sort of these steps that you have to go through. So the first thing is obviously you're updating your own Docker files. That's easy enough, and then you update your GitHub repo. And then you have to generate a new library file. So there's an official repo repository that has a list of all the repos, and you send a pull request to that with the updated file, and then it goes through some testing, and then boom, it lands today. I actually just did that, I don't know, a couple hours ago. So if you go to check the registry now, you should see that the latest versions of 0.12 and 0.10 are up there. That was actually kind of important because OpenSSL broke again. Surprise. But you know, the workflow was a bit new to us, actually, my team, because for a long time, we were doing everything internally in Git, and doing stuff on GitHub was, you know, actually took some getting used to. So that was a little bit interesting. And we're also looking at kind of ways to try and automate that stuff. As you can see with the different steps, it gets a little bit cumbersome. So I'm trying to figure out ways to just have, you know, updates to at least our repo happen automatically and include tests as well. And we also made some modifications. We didn't actually want to mess with the image itself, like add new stuff or change things or just swap out the underlying base image, because that'd be pretty disruptive. But we wanted to change some of the stuff that helped us build it. So a member on my team, Derek Crennington, actually updated the scripts that came with it. So originally, the scripts didn't really work on a Mac because of the Bash version. So we updated that, so we can basically just update the image on our laptop using boot to Docker, which is super helpful. And the other thing that I also added was just adding just a simple build test. It's like your very first test, really. It's just, does this damn thing build? We actually got burned by that once during one of the updates. So we always run that every time we do an update to just make sure all the images, all the tags work. One thing that we've been looking at is using server spec for testing and to try and automate things. I'll touch on that a little bit later as well. Now, not everyone's going to have that sort of advantages of taking over an official one. And if you're building your own image, you're basically starting from scratch. And again, the docs and everything are just really great. And also, just because everything's out in the open, there's so many images you can just look at to just see how stuff is built. And that's just incredibly helpful. Again, we had the benefit of taking over something. So, you know, we kind of had it easy. There's a lot of things you have to sort of consider when you're building this stuff, or just when you're building images as well. Like, you know, what's your base image going to be? You can't go wrong with any of the official ones. Debian Jessie is basically what's used for pretty much the majority of the official images, I think. There might be a few that are a little bit different. And if you're building from scratch, you kind of have to pick something that makes sense for you. In some cases, you might have to pick CentOS. I know that there's some software up there that, you know, they may want to use a certain thing because they've never tested on certain stuff. So, you know, Alpine's great, but they have no experience with it. So they'll probably pick, you know, one of the common distros. And of course, you want to get familiar with Docker best practices. Because we took it over, it was kind of like, you know, self-documenting. We had all these Docker files, and we're like, oh, this is, you know, this is how you do it. And the doc actually on the site was really great for that. And then you also want to think about things like, you know, tags and variants. And, you know, definitely test if the thing builds. So I mentioned tags. Tags are fantastic. So with the official Node.js image, you can pull very specific versions of Node. So you can do Node, you know, colon 0.10.34, et cetera, and you get the 12. Obviously, I just kicked off a new build today, so we're actually at 0.12.5. And so latest would point to 0.12.5. Latest is kind of like not really semantically correct. It's more like saying default. So if you just do Docker pull node, that's what you get. You don't actually get the latest thing, because the latest might be the development version, and you don't actually want that. Variants are also fantastic. So, are you serious? All right, well, I'm going to be fast. So variants are also really fantastic. So one of the things with variants is that you can provide sort of another option. So we have a slim version. So I was mentioning how Debian build packs is huge. The slim version is basically just pure Debian Jessie. And we also have a Wheezy variant as well. And if you want to see some really good examples of how this stuff is done and how it's documented, definitely check out the official Node and also the IOJS one as well. I mentioned image size. You want to kind of balance that out. Alpine is super interesting. might not be the right choice for you, but I would definitely suggest looking at it. It's only 5 megs. It's kind of crazy. Like when you download it, it's so fast it feels like it's a mistake. It is. It's like, I don't know if anyone's ever used it, but APK is like a fantastic. It's got a nice package manager. It's pretty cool. I'm working on trying to build a Linux container image for our cloud, which is about the same size, and it just provisions like a bandit. There's also something you have to deal with is user feedback. So just use GitHub issues. That works really well. Testing server spec is awesome. I'm going to jump ahead because I'm running out of time. But so there was an interesting plot twist when we took over this repo. Node and IOJS are merging. So the bottom line with that is actually things are going to be OK. We're still tracking separately. The IOJS group has lots of working groups, and they have a Docker working group. They actually invited me to join them. So I'm going to be part of their working group as we all sort of move forward with this. So in the short term, basically, we're going to be tracking separately. And then at some point, there's going to be a new Node version, and that's going to be in the repo. And then the repo is going to move over to the Node.js repo. Longer term, I think we still got a lot of things to sort of figure out. I know that there's like an LTTS working group to figure out long-term support. Like how long are we going to keep 0.8 around as a tag for the Docker images sort of up there, and things like that. I apologize for running over because I realize it's near the end of the day here, but there we go. That's it. Thank you very much.
If I end up going over, you can.
Oh, I'm going to tell you.
Yeah.
Oh, yeah.
All right, and we're going to do QA at the end. We'll probably be at the end of the session. Hey.
What do you need?
HDMI. Yep. We can do questions with the last 2 presentations since we have some time.
Sure.
Questions, anybody? You have a question there? We have the mic coming over. However, the mic is not on. Oh, we can only do one thing at a time, unfortunately.
Handheld. HH.
Thank you.
Check. Yep.
Yeah, you mentioned Alpine Linux. Do you plan to upgrade the Slim version to that?
I'm sorry.
You mentioned Alpine Linux.
Fine.
And do you plan to update the Slim version to that?
For the Node.js?
Yeah.
So that's actually interesting that it's come up. I know the IOJS team has sort of been looking at that. I think they got like an open issue to sort of look at because I mean the file size is kind of awesome, right? But it's not something we could just sort of swap out with DB and Jesse. That'd be pretty disruptive. But it could be a schema. That's exactly exactly. So it might be something we could offer as like another variant. So you can get like a Node-Alpine, and then you can get all that kind of goodness. That's something we'll probably talk about because it's kind of compelling, and I like Alpine a lot, so I might want to push for it.
Yeah, Alpine's pretty cool.
Yeah, it's pretty great.
So we can do more questions after this. The last one, and it's me. Okay, so I'm going to be giving a demo this talk. Envy new project. It's about Docker development environments, and I'm Jeff Lindsay from Glider Labs. And what we're trying to do here is reimagine the development environments, and basically we just have to be better than Vagrant. So what you're looking at here is basically an alternative for Vagrant, but it opens up a lot of other interesting possibilities. So I'm going to jump right into a demo, and luckily it's pre-recorded for you. So Envy is a development environment manager. I actually made this Thursday when they asked me for my slides for this thing. So we're going to run it on DigitalOcean. It's a Docker container. You just run it. You want to expose port 22 or publish port 22. The host port 22, we actually changed to 2222. It's a better experience to just have Envy owned it. So now that we have it running, we can actually SSH into NV, which is the primary way you kind of work with NV. So with the IP, so we're going to log in with my GitHub username, and it's going to automatically go and look up my SSH key on GitHub. So there's sort of no configuration. You just use your GitHub account. And so now we're in a development environment that is in a container. And so there's, it's based on base Ubuntu, but because it's in a container, we can do all kinds of stuff like delete files. But if we reconnect to it, we actually get just a reset environment. So you can kind of do all kinds of stuff like that. You can actually do that same thing from within the container. So let's add a file, and so now we have a hello file, and we can actually run reload, and it will reset it in the same SSH session. So the default state of this is defined by a Docker file, which actually lives in an environment directory that's been mounted in here. So we can actually edit the Docker file for this container from within the container. So we see the Docker file as from Ubuntu. We can append to it some apt-get stuff. We'll add Docker. We'll add Redis. And we'll add Vim for the hell of it. We'll just append that to the Docker file. And we're going to show you that. And then we're going to run a command called rebuild, which will rebuild the container from inside the container, although it's not really inside the container. But so it's rebuilding it, and then it's going to drop us back into that environment. There we are. And so now we have Redis, we have Docker, and we have Vim, as you can see. So what else? Oh, but if you want to add incremental changes to this, you can still add files and then run commit from inside the container, and it will commit it, and you can reload, and this stuff will still be there. But of course, if you do a rebuild, it will go back to the state after a build. So those are the basics. The other thing is the root home directory, since that's the default user, is persisted as a volume. So anything that you put in there is sort of, it can be, you can reload or rebuild, and the files will still be in there. So those are the basics. But the other thing is you can have tons of environments, as many as you want. You just have to name them. So there's a command called switch, which you can call from within the container. And you just come up with a new name for an environment. We'll say alpha. So now we're in an alpha environment, which is a different container, and it's reset to the defaults of what a new development environment looks like from Ubuntu. We can actually change the distribution of Linux for our development environment from within that environment by editing the Docker file and rebuilding. And so we're just changing it to Alpine. Our development environment is now Alpine. From within here, all our commands work as usual, though we have to call exec in Alpine. We'll switch back to program. Now we're in program. We have Vim, Docker, Redis. We can switch back to alpha. We have our Alpine image. What else? Oh, we can SSH directly into an environment. We just add plus the environment name, and we SSH directly into that environment. We can actually create new environments from that as well. So just give a new environment name, and we have a new environment to mess around with. But let's switch back to the default environment program and talk about Docker. So far, Docker's been behind the scenes. You can actually use Docker in here. And we ran this in Docker. We ran Docker. We don't see anything because it's a private Docker instance for every environment. You can see Docker host has been set up. And so all you have to do is install Docker, and you have a private Docker instance for every environment. So let's do a Docker run, and we'll run interactive Alpine shell. That's pretty quick. And so now we're in Alpine. And I had to pull it again because this is a new private instance of Docker. We can actually SSH into my environment again and use Docker to see the other session running that Alpine container. What else? Let's run Redis. Let's run Redis and publish the default Redis port. And this works as you would expect it to work in a VM or Vagrant or whatever. So we're going to pull Redis, and then it will be running. And so now we can see that Redis is running, published on the default port. And we can actually just use Redis against localhost and it just works. So now every environment can have its own private database, state, whatever. All the Docker containers are persisted across sessions for a particular environment. If we switched over to a different environment, well, we don't have Docker in there, but it is set up for Docker. So you can see we have the Docker host set up. So all we need to do here is install Docker, which is pretty straightforward. In Alpine APK, add Docker. We'll also add Redis. And gee, that was pretty fast. So now we have Docker, private Docker instance. So let's actually go back to our host system, the DigitalOcean droplet. What's actually running there? If we do Docker PS, it shows us what's running. We have our Envy instance running there at the bottom, and then for every session we have a container running, and then for every environment there's a Docker and Docker instance, which is not based in Alpine, so we will fix that. What else? So that's pretty cool, right? Wait. By default, running this, you can access any environment via the browser with a web-based terminal. This is based on H-term. It's Chromium's terminal implementation, super fast, full terminal implementation. Normally this would ask for my GitHub credentials to authenticate, but I can do everything that I could do in SSH in these development environments in the browser. I can also go directly to any particular environment that I've created. Let's go into beta, that one we created a while back, and see that, yeah, it's from Ubuntu. So yeah, that's Envy. It's less than 200 lines of code and was made in 24 hours. That's it. You didn't call me out. 10 minutes. Questions for anybody? We'll let the mic man.
For Envy, how about those of us who don't program in the terminal?
So the roadmap for this is quite exciting. NFS, you will be able to, in the same way you can with Vagrant, access files on your host laptop or whatever. It'll just be built in.
Jeff, are you secretly a robot?
I don't know how to answer that. So
Sounds like what a robot would say.
Does the browser-based TTY require a Chrome extension, or is it just a
Nope.
site?
Just
Cool.
works. Actually, I have not tested it anywhere else. From what I understand, it should work in various other browsers, probably Safari. I don't know about Firefox, haven't tried it. It does work in Safari. One moment, please.
So you mentioned that you want to beat Vagrant. So how are we beating Vagrant if you're not offering all the automation that Vagrant provides, such as being able to provision using something other than Docker?
Lovely question. Use Vagrant for that. I mean, really, think about how I use Vagrant. You know, these days I use Vagrant to run Linux, to run Docker, and to install any other development things. You know, you could run. I also run boot to Docker, but then you know, it's still, you have to kind of manually manage your containers that you would use for a development environment. It just doesn't feel right for development environment stuff. But if you think about what normally people do, it's like they'll set up maybe a Vagrant file for every project, and they have to Vagrant up a VM and then Vagrant down to switch to another project. And maybe they have to, and I don't do that, so I'll make one Vagrant file for my entire development, everything, and so I just install everything in that one Vagrant, and it's just a mess. right? And then you might have, you know, you work with an organization like DigitalOcean, and they're like, here's our development environment, and they give it to you with a Vagrant box. Of course, that big, giant Vagrant box is like, no, they're never going to update that, and of course, you're going to customize it, whereas this is much more lightweight. In fact, you don't even have to really install anything. This is really great for tutorials, you know, workshops and stuff like that. Any situation where you're like, man, development environments suck to set up, right? Because you can just say like, I made it here SSHN, and now you have a development environment. So there's a lot of stuff on the roadmap with like shared development environments. So you can, like, your organization can pre-bake environments, and people just have them. And if you've seen term share, well, I won't get into all the crazy stuff that's going to be added, but does that answer your question? There's a lot of stuff that Vagrant does that I don't really consider like development environment important stuff. I don't use most of those features, so maybe maybe the project will address those, but yeah.
Yeah, you've shown how you can modify the container live and then commit.
Yeah.
Can you go back?
Nope. Who were you at the? I was at a panel and I gave a secret version of this talk, and someone asked the same question.
Okay, no, it wasn't me.
My answer would be you should version control the Docker file.
Okay, but what about like the side effects that you do like manually, not inside the Docker file? Like if you.
Oh, the commits.
Yeah.
Well, commits sort
Yeah,
of
commit.
like it's not the way you would normally do it. Like you ideally, and what this kind of does is it lets you define your development environment with code as opposed to the incremental stuff you normally do with a VM.
Yeah.
Right.
Yeah, but what's nice is that you can like try stuff like interactively, and if it works, like consolidating in the Docker file.
Yep. Yep.
So
I mean, you can use that as a way to roll back, try stuff, maybe commit, and then you're like, this isn't working, rebuild, and you're back
So
instantly.
if you committed a bunch of stuff, and then you end up making a mistake, how do you? Is there a way to go back to?
I mean,
okay, you can
with
go back
it right
to
now.
Okay.
You just like rebuild and start over.
Okay, yeah, cool.
All of this is way better than dealing with VMs. So.
Oh yeah, I agree.
Last one. Yeah, last question. If there's anybody.
I wanted to know who you work for.
That's it? I work for Glider Labs. It's who here has used Docker since 2013 when it came out? Show of hands. Some old school people. Who here has used Docker since 2012? Really? Did you work at .cloud?
I don't, but I had access to the repo.
So I worked on the Docker project at .cloud as an independent collaborator, and then since then, because it kind of took off, I started Glider Labs to do consulting around it. We work with clients. We're actually primarily a independent systems R&D lab, where we do tons of open source stuff around Docker, Registrator, Logspout, Alpine, a lot of other cool stuff. But our money comes from working with clients and sponsorships and stuff like that. So if any of you want to work with somebody who's been working with Docker and help design Docker, you can work with Glider Labs, and we'll kind of help you set up with a really simple deployment pipeline. Glider Labs was started with Andy Shin over there, who maintains the Alpine package. Does that answer the question? Cool, thank you. Are you sure there's no questions for? Sorry. Okay, cool. So the lightning talks are happening again tomorrow. I think a little bit earlier. But yeah, thank you for coming.